Hello students, we are going to learn second rule of DUIS, differentiation under integral sign. See the statement of this rule. If f of alpha is equal to a to b f of x alpha dx, where a and b are functions of the parameter, alpha is parameter, a is f1 alpha, b is f2 alpha, then f dash alpha is equal to a to b dabba by dabba alpha of f of x alpha, f of x alpha, f of x small, f of small, this one is small, plus two more additional terms as compared to rule 1, db by d alpha f of b alpha minus da by d alpha f of a alpha. So what we do here, two additional terms, b, that is upper limit, to be differentiated totally with respect to alpha, and where integrand, the function to be integrated where x is replaced by b, then da by d alpha and x is replaced by lower limit a. So this rule is applied if the limits of integration are not constants. Constant means 0, 1, pi by 2, it is something like this, or the limits are depending upon parameter alpha. So let us see some illustrations on this rule. So the first example, if f of a is equal to pi by 6 times a to pi by 2 times a sin x upon x into dx, then show that f dash a is equal to 0, where a is parameter, See, if you observe here, the limits are not constant. So these are the limits. These are not constant. These are depending upon parameter a. So that's why we apply second rule of differentiation under the integral sign. So it is given f of a is equal to pi upon 6 times a to pi upon 2 times a sin ax upon x with respect to x. I call this is 1. Using DUIS second rule, right now I told you, so f dash a, this is equal to pi by 6 times a, differentiating under integral sign, 2 times a, dabba by dabba a of sin of ax upon x into dx, plus d by dA of upper limit, pi by 2 times a, and here wherever x is there, it is replaced by upper limit pi by 2 times a divided by x also replaced at the denominator pi by 2 times a minus d by dA of lower limit pi by 6 times a, and wherever x is there, it is replaced by lower limit, same thing, pi by 6 times a divided by pi by 6 times a. So this is application of the rule. Now further simplification, pi by 6 times a, so with respect to a, keeping x as a constant, so derivative of sin x cos ax into differentiation of ax with respect to a, that is x divided by x into dx, plus now derivative of this, total derivative with respect to a, minus pi upon 2 times a square, and here a gets cancelled. Sin pi by 2, its value is 1 upon pi upon 2 times a, minus here also derivative of 1 upon a minus 1 upon a square means pi minus pi upon 6a square, and then here also a gets cancelled. Sine of the angle pi by 6, it is 1 by 2 divided by pi upon 6 times a. Now further simplification, this x gets cancelled. Integration of cos of x is sin x upon a with respect to x, of course, pi upon 6 times a to pi upon 2 times a, and this we simplify this further, minus pi upon 2a square into 2a upon pi, minus, this is minus plus pi upon 6 times a square multiplied by 1 by 2 into pi upon 6a upon pi. So we simplify this further. So this would be something 1 upon a, we apply upper limit, sine of a pi upon 2 times a, x is replaced here by upper limit, minus sine of a pi upon 6 times a, minus this 2 gets cancelled, pi gets cancelled, minus 1 upon a also gets cancelled 1, and here also pi gets cancelled, 6 gets cancelled, minus, you are getting this as minus 1 upon plus 1 upon 2 times a. Now we simplify this further. So this would be something, this is equal to, or f of a, f dash a is equal to, now this a also gets cancelled from here. So sin pi by 2 is 1 upon a inside the bracket, 1 minus sin pi by 6 30 degree 1 by 2, and this would be minus 1 upon a plus 1 upon 2 times a. So this is 1 minus 1 by 2 is 1 by 2, means 1 upon 2 times a minus 1 upon a plus 1 upon 2 times a. So this is 1 upon 2 times 1 upon 2 times means 1 upon a minus 1 upon a is equal to 0. That is f dash a is equal to 0. So this is the way we apply this second rule of differentiation under the integral sign. So there are more examples on this differentiation under the integral sign. Second rule, that is limits are not constant, that is limits are depending upon parameter given. So we go for the next example. Verify, second sum, verify the rule of DUIS for f of a is equal to 0 to a square dx upon x plus a. You have to verify the rule. Verify means what you have to do exactly. See, verification of the rule means you have to find actually f dash a by actual integration and f dash a by the rule. If they are true, they are same, they are equal, then the rule is verified. So f of a, it is given as a 0 to a square dx upon x plus a. We find out by actual integration. So this is equal to integration of this. It is log of x plus a, that is ln of x plus a, natural log 0 to a square. So this is equal to, I apply the upper limit and lower limit. Upper limit if I apply, log of a square plus a, x is replaced by a square, minus log of x is replaced by 0, so it is something, this is equal to log of a into a plus 1 divided by a gets cancelled, so we got this log of a plus 1, this is f of a actually, so we need f dash a, therefore f dash a means derivative with respect to a, it is 1 upon a plus 1. I call this is expression number 1. Now we find out value of this f dash a by using second rule. By second rule of DUIS, from this expression I will be calling this is 2 and this is 1. From 1 f dash a, now we apply second rule because limits are depending upon parameter a, f dash a 0 to a square dabba a of 1 upon x plus a into dx plus, now d by dA of upper limit, that is a square into 1 upon wherever x is there, it is replaced by upper limit a square plus a and minus d by dA of lower limit 0. So this 0 multiplied by the whole thing, it is to be 0 there. Now we take the partial derivative 0 to a square. Now what is partial derivative of this with respect to a? Minus 1 upon x plus a bracket square and plus into dx, here 2 times a multiplied by 1 upon a plus 1. So we got this as integration of this 1 upon x plus a, limits applied 0 to a square with respect to x we are taking, so x plus a bracket raised to minus 2 plus 1 upon minus 2 plus 1 plus a gets cancelled 2 upon a plus 1. If you apply the limits here, it is something like this, upper limit is a square, we replace by x a minus 0, if we replace x by 0, 1 upon a plus 2 upon a plus 1. So I take the LCM here, 1 upon a plus 1 minus 1 upon a plus 2 upon a plus 1. I take the LCM, it is a plus 1. So you are getting 1 minus a minus 1 plus 2. So this would be something, this is a plus 1, here 2 times a is there. So we simplify this and see what is happening. So this is a divided by a plus 1 means it is 1 upon, this gets cancelled, a plus 1, so this is third. So from 2 and 3 f dash a is same, hence the second rule of differentiation under the integral sign is verified. From 2 it is 1 upon a plus 1, from 3 it is 1 upon a plus 1, hence the rule of second rule of DUIS is verified. So we go for the next example on this second rule of differentiation under the integral sign. So the next example is, if yx is equal to, third example, if yx is equal to 0 to x f of t sine of a x minus t dt, sine of a x minus t dt, then show that y double dash x plus a square y this is equal to a into f of x, a into f of x. Now if you observe here, limits x is parameter, here x is parameter, integral given with respect to t, so x parameter, and limits are depending upon parameter. So we apply, this means we have to show d2y by dx square plus a square y is equal to this, we have to show. So we have to apply second rule of DUIS 2 times. So it is given yx is equal to 0 to x f of t sine of a x minus t dt. Applying second rule of DUIS second rule. So y dash x means it is dy by dx. In fact, this is equal to 0 to x dabba by x of f of t sine of, it is ax minus at into dt plus d by dx of upper limit, it is x, and multiplied by this function wherever t is there, because it is with respect to t is replaced by x, means f of x into sine of ax minus ax, and lower limit if you observe d by dx of 0, so it is automatically vanishing, so no need to consider that. So this would be 0 to x, then this would be f of t constant, differentiation of this with respect to x, cos of ax minus at into a into dt, plus this would be 0 because sine 0 is 0, need not be considered. So this is y dash x. Now we have to apply this rule again, means y double dash x we have to find out. Applying again the DUIS, applying DUIS again. So what is happening? See, y double dash x, this is equal to d2y by dx square, this is equal to, now here 0 to x dabba x of f of t cos of ax minus at and dt plus upper limit d by dx of upper limit is x multiplied by, this is integrand, the function to be integrated, where, so here a is there, so a may be taken outside or a is here, so it is, so I just take a outside completely, so this would be f of x, t is replaced by x here, cos of ax minus ax, and lower limit minus d by dx of lower limit 0, need not be considered because it is becoming 0. That is d2y by dx square, this is equal to a inside the bracket integral 0 to x and derivative f of t, and derivative of this, it is minus sine of ax minus at into derivative of ax minus at with respect to x, it is a, and plus, now here this is 1 f of x multiplied by cos 0, it is 1, so need not be considered. So we simplify this now, this is a, so this we just simplify this and get the answer. a f of t. This a means it is something like this, minus this a and a, it is minus a square, 0 to x, 0 to x, 0 to x, f of t sine of a x minus t dt plus a is multiplied here, a into f of x. Now if you observe this, so you'll come to know this is y of x actually. So you are getting this as d2y by dx square, d2y by dx square. This is equal to minus a square. Actually y of x, this the underlined expression. This is y of x plus a into f of x. So you are getting this as d2y by dx square plus a square yx. This is equal to a into f of x. So this is the way it is being proved here. So sometimes you need to apply second rule of DUIS. Second rule of DUIS so many times, 2 times, 3 times also you can apply. So this is difference between first rule and second rule of differentiation under the integral sign, and effective execution of the rule, first rule for the constant limits and second rule for the variable limits or limits depending upon the parameter. So you have to note it very carefully. That's all.